Good morning everyone. I am Dr. HimaBindhu from Department of Mechanical Engineering, Institute of Aeronautical Engineering. And I will be dealing the robotics subject, in which my today's topic is hydraulic actuator. What do we mean by actuator exactly? As we have discussed in the earlier class about the actuator, and we've discussed about the types of actuators, and in detail we have studied about the pneumatic actuator, right? So in today's class we will be studying about the hydraulic actuator. Let us once recap what is the use of an actuator, right? What is an actuator? Actuator is something which is used for the movement of the robot's manipulator. When the manipulator has to move or it has to change its position or orientation, the actuator plays a very important role in robotics. Right? So, coming towards the hydraulic actuator, as the word itself implies, hydraulic means what? What is the mode of movement we are using in this particular robot? So, here we generally prefer oil or any particular type of the fluid, liquid fluid, right? So, in the hydraulic actuator, we generally use oil or the fluid, that is liquid fluid, for the movement of the manipulator. That is, with the amount of the pressure being created within the cylinder, the piston movement will be done according to which the position or orientation of the robot manipulator will be moving. Then we can see a figure here, right? So this particular figure implies the hydraulic actuator, where we have a reservoir, right? Where we have a reservoir in which we have the fluid being placed, and this particular reservoir is being attached to the filter, and the filter is being attached to the pump, and from the pump it is going moving to the particular hydraulic cylinder, where in this particular hydraulic cylinder we have the piston or shaft being placed, right? So here the fluid whatever is being placed inside the reservoir will first get filtered, so that there are no any sort of dust particles or any sort of minute dust particles. If they are there, it gets filtered in this particular filter, and with the help of the pump will pump the fluid from the reservoir through the control valve, and then that particular fluid is being sent into the hydraulic cylinder in this particular direction, right? So here the control valve is being placed so that when any particular type of the pressure is being increased, here the control valve controls the pressure, and whatever is the required amount of the fluid being sent into the cylinder is only being sent, right? So as the fluid is sent into the cylinder, there is the movement, there is a amount of pressure being created, and with that particular pressure there is a forward movement of the piston or the shaft, according to which the robot manipulator will be moving, right? That is, the hydraulic actuator is a device which is used to convert the hydraulic energy into the mechanical motion. Clear? It is a device which is used to convert the here whatever is the fluid pressure being increased, it is being converted into the mechanical motion. That is the motion or movement of the robot manipulator. That is, hydraulic device is one of the important device which is used to convert the hydraulic energy into the mechanical motion for the movement of the robot manipulator to be done, right? So in robotics, they are favored for applications requiring high force and power density. So generally, we require high force and power density. We use this particular type of the component. And as we have discussed in the figure, there are various components like hydraulic cylinder. It is a hydraulic cylinder is used to convert the hydraulic energy into the mechanical motion. That is, it acts as a medium through which the pressure is getting transmitted. That is, the fluid, whatever is being placed inside with that particular pressure, it is being converted into the mechanical energy. And the pump is used to pump the fluid to the hydraulic cylinder. The valves are used to control the flow and direction of the fluid from the reservoir, right? The control valves are used to control the pressure and the flow of the fluid into the hydraulic cylinder. And here we have two types of cylinder, right? That is, here we have two types of actuator. One is the linear and the rotary actuator, right? So this would, depending upon the requirement, we will be using the types of actuator, right? Now coming on to the actual features of the hydraulic actuator. What is the use? What are the requirements, right? It is generally the hydraulic cylinder is used to pressurize the fluid to transmit into the control power, right? And this particular device is mainly suitable for heavy load robot application, wherever the high load applications are to be done. In that particular area, we use this particular type of the hydraulic actuator. That is, wherever we have heavy loads to be lifted, wherever in large scale industries, we use this particular type of the robots, right? That is, the term hydraulic itself refers the transfer of the energy from pressure difference to the kinetic energy of the flow. And the features, the main important features of this particular actuator is high force capability, high dynamic response, braking torque, good mechanical stiffness, and high power per unit weight and volume. Right? And coming to the advantages, here this particular type of the actuator has no reduction gear. In this actuator, there is no requirement of the gear reduction, and it gives high accuracy and better response compared to that of the electrical or pneumatic actuator, right? And it is generally used, as I've told you, for heavy duty and large robots, and it provides more power than that of the electric driven, as I've discussed earlier, right? But there are some disadvantages for this particular type of the hydraulic actuator. What are they? Since we are using oil, or since we are using this particular fluid, there may be a leakage problem, right? There may be a leakage problem. Due to this particular leakage, there will be high maintenance, right? There may be a leakage for if anywhere any pore or any valve is slightly leaking. What happens to that particular actuator robo? It requires more maintenance, and since we are using a hydraulic actuator, it is more expensive than that of the pneumatic or the motor driven actuator, and it requires a clean environment. It is not suitable for generally clean environment because it contains oil and there is a leakage problem, so it cannot be used somewhere in the areas where the robot is being used for electronic chipping or any other core, in any particular medico robots. We cannot use this particular type of the actuators, right? And it requires more floor area because the setup of this particular hydraulic actuator is very big. It requires more setup area. Here we have the types of hydraulic actuator there are two types, as I've told you, linear and rotary actuator. Again, in this particular linear actuator, we have two types, that is single acting cylinder and double acting cylinder. Whereas in the rotary actuator, it generally occurs in the rotational form, whereas in the linear actuator, it is acting in the form of a piston, whereas here it is acting in the form of a wheel. So here this again has been divided into vane motor and piston motor. So generally in the single acting cylinder, what happens is there is the movement of the pressure whatever is being developed will be applied only in one single direction. So it is been applied only in one single direction, whereas here when we take the rotary, it has been in a squirrel, that is, it rotates in a particular form. It is that is the pressure whatever is being developed, it is in a rotational motion, right? Whereas when we come across the linear actuator or single acting actuator, the pressure is being applied only in one particular direction, whereas in double acting it acts in both the directions. The fluid whatever is being pressurized in the cylinder will act in both the directions, right? Whereas in the vane motor, what happens is the vanes are in the rotational direction, the pressure will be applied in the rotational motion. Now these are the figures of the single acting. This is the single acting cylinder, this is the double acting cylinder, and this is the vane motor. So as you can see here, this is the hydraulic cylinder being placed, within which we have this piston or the shaft being placed, and this is the piston steel, this is the vent valve. With the help of this spring, there is the movement of the shaft being taking place, and from this we get the pressure of the fluid which has been sent into the hydraulic cylinder. As the pressure increases, the piston is moving in the outwards direction. As the pressure decreases, it moves back to the inverse direction, and accordingly the movement of the manipulator will be done. Whereas in the double acting cylinder, what happens? There is a dual action. There is a dual action of the piston being taking place within the hydraulic cylinder. Now this is the end cap of the hydraulic cylinder. This is the cushion seat. This is the cushion piston, and this is the actual piston being placed within the hydraulic cylinder. And this is the piston rod. This is the flow control valve. This is the bearing cap, right? As the fluid is entering into the cylinder, as the pressure is being developed into the cylinder, there is a movement of the cylinder in and out of the hydraulic cylinder in a dual direction, right? That is, here it takes place, and here also it is taking place. That is, in the dual action, in the dual the hydraulic cylinder, the piston will be acting in a dual role. That is the reason it is named under double acting hydraulic cylinder. And generally this particular type of the hydraulic cylinders are generally used for large scale industries, where the movement of the rowboat has to be done at a heavier load, and when it needs to carry heavy load objects, generally we use this particular type of the hydraulic actuator. Whereas when coming to the vane motor, this is acting like a centrifugal force. There is a pressure being created in the centrifugal direction. That is, as the liquid enters through the inlet, the vanes start rotating. That is, the rotors start rotating, according to which the vane starts rotating and creates some amount of the pressure in this vane motor, and this is generated into the mechanical energy or mechanical power, right? The pressurized fluid is being converted into the mechanical power, same as that of the centrifugal turbine or centrifugal force acting on the particular turbine, right? That is, as the fluid enters into this particular port casing, this rotor starts rotating, along with which the vanes start rotating and create some amount of the pressure, due to which the pressurized fluid is being converted into the mechanical energy or mechanical power, and the movement of the robot manipulator will be done. Clear? So coming to the applications, generally where do we use this particular type of the hydraulic actuator? So in the industrial robots, in construction, generally in mobile robots also you use, and in medical robots. That is, for surgical robots that require precise and powerful movement, we generally use this particular type of the robot. Whereas for welding, for forming, heavy material handling, or for when we apply higher force, we will be using this particular type in industrial robots. Or when we come across loaders or heavy machinery or excavators, generally for that particular type of the application, we use a construction robot. Whereas for agriculture, mining, or any particular high forces, we use the mobile type of the robot. So these are the 4 applications where we can use the hydraulic actuators more predominantly. and it has different control system with the help of which it will be acting, that is proportional integral derivative control, model predictive control, and servo valve control. So based on these particular control systems, the robot actuator will be working. That is commonly used for controlling the position and speed of the hydraulic actuator. We use the proportional PID control. For advanced method, we go for the MCB control. And when we require high precision to be done, right, where the response of the control system should be more accurate, there we use this particular type of the servo valve control, right. That is generally when we have to control the position and speed, we use the PID control system. If we come across the predictive model, or where based on the control system where we need to go for predictive model, there we use the model predictive control system. And for a precise conditions, for where we require more accurate response of the control signal, there we use the servo valve type of the control systems. And when we are moving forward, we need to know what are the latest innovative trends where we can use this particular hydraulic control systems, not only in the robotic system, but other than this, as the industry is being developing in the large scale, we need to go further. We need to search for new trends and technologies. So generally, these particular hydraulic actuators also can be used in these particular new trend areas. That is electro hydraulic system. We can use. We can use this hydraulic actuator as a smart hydraulics. We can use as a energy recovery system in using the Internet of Things, by using the Internet of Things. So for real time monitoring, we can come across the smart hydraulic systems, that is for integration of the sensors. In order to generally integrate the sensors with the help of the Internet of Things for real time monitoring, we come that particular technology comes under smart hydraulics. And when the hydraulic system needs to improve its efficiency, depending upon the capture of the technologies on rescue of the energy, then we call that as the energy recovery system. Or when we need to combine the electric motors with hydraulic system, we come across the hydraulic system. That is, we need to upgrade ourselves. We need to search for new innovative new trends and reduce this traditional model, and we need to come for the upcoming new trends, right. So generally the hydraulic actuators is one of plays a very important role in the robotics, where it is used for high forces, for heavy jobs, for precision control, and for more reliable accuracy. We use the hydraulic actuators, which they generally are used for complexity and maintenance, ongoing innovation continue, or for various different other applications. We use this particular hydraulic actuator system. Clear? So in the last class, we have discussed about the pneumatic, where we have used air as the mode, and here in today's class, we have come across the hydraulic, where we are using oil or fluid as the mode to generate the mechanical energy. In next class, we will be discussing about the electromotor or stepped motor type of the actuator. And we will see, after that we will see the difference between all these particular three actuators, and which is more useful in today's trend, that we will be learning in the next session. I hope you have understood. Thank you. Signing off for today, Dr. G. HimaBindhu.
Like, share, and subscribe. Hit the bell icon for more updates.